and it's titled Elevating Your Streaming Experience with Just Noticeable Difference-Based Encoding. Hello.
Okay, hello everyone. My name is Jingwen. I'm a PhD student of Nantes University. I will make a presentation of our co-work with Hadi, Vignesh, and Raymond and Patrick, my supervisor. The title is Elevating Your Streaming Experience with GND-Based Encoding. So first, I will introduce what is GND, SUR, and our motivation. And then I will introduce the solutions that we proposed. And finally, the work in progress. So first, what is just a noticeable difference in our research? Supposing that we have source content, with a given codec, we can compress it with different encoding parameters, for example, QP from 1 to 51. And here, these figures shows the relationships between the quality and bitrate. The green point is SRC, which has the highest bitrate and the best quality. And the more we compressed, the bitrate will reduce and the quality will degrade. However, human eyes cannot perceive every point in this curve. As shown in the red curve, if we take the SRC as anchor, human eyes will begin to perceive difference until the first red point, which will be called the first GND. And if we take the first GND as anchor, and the next point human eyes begin to perceive difference will be called second GND, etc. The scope of our research is first, the GND here are not pixel-wise, we use video-wise GND, and the distortion we focused is on video compression, and the proxy of GND could be QP encoding parameters, for example, QP, CRF, and VMAF bitrate. And so what determines the value of GND? There are three factors. The first is display settings, for example, the viewing distance, ambient light, the monitor profiling. And the second one is the subject. For someone who is more sensitive, he will perceive the difference earlier. And for someone who is less sensitive, he will perceive the difference later. And the third one is the video content. So in our work, we focus on how different video content impact the location of the GND. Factor 1 and 2 are fixed and not investigated. And then, as I mentioned before, the GND for different people is different. SUR curve is determined by the GND of a group of viewers. For a given content, if we conduct the GND subject test for a group of observers, for example, 30%, then we can obtain the distributions of the GND of them. As shown here, the blue bars are the distributions for a given content of this group of persons. If we assume that this distribution follows Gaussian, then we can obtain the PDF of this distribution. And in probability theory, we can easily obtain the cumulative distribution function, CDF, by the integration of the PDF. And the SUR is defined as the complementary of the CDF, 1 minus the CDF. So what does it mean exactly? We can have a look. It's a green curve. Green curve. So for the QP value very small, for example, QP1 from 1 to 50, the SUR curve equals to 1, which means no one can perceive the difference. Everyone is satisfied. And for the QP value very large, we can see that the SUR curve equals to 0, which means everyone in the group perceives difference, so no one is satisfied. The most, so for a given content, if we can obtain its SUR curve, then it can guide us to determine the encoding parameters with the given threshold of SUR. The mostly used SUR threshold is 75%. In this example, when SUR equals to 75, the QP value equals to 28, which means if we encode the video with QP 28, 75% users is satisfied. They cannot perceive any difference with the reference, compared to the reference. Okay, So the motivations, we know that in streaming, each video content is encoded at multiple bitrate and resolutions, and a convex hull is formed based on the quality of the encoding. So the question is, which encodings to select from the convex hull to construct the bitrate ladder? So GNDs can help us to select encodings with to prevent us to select similar representations, and it can help us to use the least resources for the same qualities. So now let's come to the solutions. The first, I would like to introduce the open, public available large-scale GND dataset, which is called VideoSet. There are 225-second SRC, which is encoded with H.264, QP from 1 to 51, and there are 4 encoding resolutions. So if we if we ask the question, like the VMAF difference equals to how much, like we can, for people, they can perceive the difference, I will say it's very content dependent. So on the right is the distribution on this video set, the delta VMAF, the distribution of the delta VMAF. So just to be clear, the delta VMAF is the VMAF of the anchor and the VMAF of the 75th percentile SUR. So we can see from this distribution that for some content, the delta VMAF larger than 15, people cannot perceive difference. And for some content, even the delta VMAF is smaller than 1, people can perceive difference. So based on that, there are 2 work proposed by us. The first one is anchor quality dependent GND. In this paper, we can find a lookup table that for different quality for your anchor, what is the delta VMAF for GND. And the second one is a content-dependent GND, which is learning trend and test on the video set with a machine learning model. And then the VMAF proxy can also help us to optimize the subjective test. For example, in the video set, QP as a GND candidate playlist is QP from 1 to 51. But we know that for QP 51, for sure, it's worse quality. People can perceive difference. So it's useless to include it in the GND candidate playlist. By the VMAF proxy, we can make a pre-processing to reduce the GND candidate playlist. And with our simulation, we can reduce the subject test duration to 7% without losing the GND information. Okay, and now the previous VMAF proxy, we are only focused on the 75th percentile SUR. Here, I would like to target the SUR modeling and prediction for the entire curve. So there are several works aimed to solve the GND and SUR problem. However, they have 2 main drawbacks. The first is they are modeling SUR curve by Gaussian distribution. However, when we revisiting the original annotations of this data set, we found that the Gaussian distribution is not necessarily the best modeling, as we can see here. And the second drawback is all the models are predicting the entire SUR curve point by point, which means in order to obtain the SUR curves, the SRC need to be compressed into every possible PBS. For example, here is QP from 1 to 51. And then the input of the model is the SRC and the encoded PBS to obtain 1 SUR scores, and they do it for every PBS to construct the SUR curve. This is very expensive to compute, and also the curve obtained by this is not monotonic nor increasing, which is not good. And so we proposed a pipeline for the SUR and GND modeling and prediction, which include 2 parts. Modeling, the modeling part aims to find the best mathematic distributions for the GND for group viewers. And then with it, we can find the best fitted parameters, which will be used as ground truth for the predictions. And for the predictions, we just use the SRC as input. We extract features and then fit the features to the machine learning-based regression models to predict the parameters and then reconstruct the SUR curve. And we can, from our paper, we see that the Gaussian distributions are not the best options for GND modeling. And for SUR curve prediction, parameter-driven approach are much less complex, and it gives us promising results. So, and last, the accuracy, and we still have a lot of space to improve, and we can, to make it into real production, we still need to reduce the complexity. And also, we would like to visit SUR and GND modeling and prediction based on different proxy, for example, bitrate, CRF, etc. That's all.
Okay, thank you very much for the interesting talk. Questions? Have several minutes for questions. Yeah. You like to ask questions? This is good. Yeah, that's better.
Interesting talk. Thank you. This is very interesting, and we are very familiar with that video set. I have a couple of questions regarding this, but we'll keep the questions very short. The very first thing is that why you chose 75 percentile to identify JND?
This is the question that everyone asks me. I cannot really answer this because this is what everyone used. I think that is why we are modeling SUR. Then, if we model SUR, we can choose whatever we want. If we have more money, we can choose to satisfy more users.
This is one. The second thing is that, have you done any further subjective study yourself? I know that Patrick is very good in doing subjective study. He has a lab to do that.
Yeah, we are doing a subject test with Amazon Prime Video, and unfortunately, with the license problem, we cannot make it public.
The third thing is that have you identified JND for VMAF using your approach? And can you disclose that?
For VMAF, the work we already did is with just the 75 percentile VMAF, and the prediction error is around 2. MAE is around 2.
Okay. And you have published this, right? Or they have? Okay.
Yeah, this is published.
Okay. Thank you.
Okay. More questions? Excellent. So in such a case, let's thank the speaker.